Okay. Hello, everyone, and thank you for joining us for our 7th chapter of the AIA Climate Action webinar series. I'm Bill Leddy, AIA's California's Vice President of Climate Action. In the event that you have missed any of the first 6 webinars in this series, be sure to check out the Climate Action portion on the AIA California website for recordings, most of the slide decks, and additional resources. And as always, we will provide the recording and any PowerPoint presentations from today's panel discussion on the website as well. For the first time, today's Climate Action webinar will be a panel discussion format and will be centered around designing for ecology, one of the 10 pillars of the AIA framework for design excellence. So when you're using this looking through this lens and at your next project, we hope you'll be thinking about protecting native habitats through creative landscape design, fostering local biodiversity, paying attention to dark skies and night pollution, making your buildings bird friendly, and also paying attention to site acoustics and many other factors that the panelists will address. Before I introduce our moderator, just a quick reminder on how to ask questions. If you have any questions, please use the Q&A box in the lower or upper menu bar of your Zoom window to type in questions to be answered during the Q&A portion at the end of the webinar. For any questions left unanswered, our panelists will provide following the webinar, and we'll provide information following the webinar, and we'll also include those on the Design for Ecology webinar page. Now let me introduce our moderator, Catherine Spitz, trained as a painter and licensed as both landscape architect and architect. Catherine Spitz views landscape as the means to reconnect people to nature. In our increasingly fragmented and urbanized world, we have become distant from the ecologies in which we live. Landscape architecture inspires us to understand, value, and preserve those critical ecosystems. Catherine Spitz founded Catherine Spitz Associates, Landscape Architecture, now KSA Design Studio, in 1994 in Los Angeles. Focusing on urban projects, the firm's work includes award-winning projects of all scales, including public streetscapes, parks, playgrounds, campuses, and restorations, to private gardens in both the United States and abroad. Each project tells a design story related to the site, its cultural memories, and the regional landscape. She currently lives on the Monterey Peninsula, where she has rediscovered her passion for designing gardens which reflect the native California landscape and extend the interior into the exterior. So with that, I'd like to introduce Katie. And Katie, please take it away.
Okay, we're gonna go here, share. And start. So first of all, I want to tell everyone we have not forgotten water. Water was a subject of an earlier webinar. Today's talk on earth, air, and fire, the intersection of ecology and architecture in our catastrophic world, is really about thinking outside the box. So we all recognize that we live in a world where the ecologies that support life are being threatened by the catastrophic effects of climate change, and that architecture, which consumes huge amounts of energy and emits huge amounts of CO2, makes us as guilty by association of some of the most adverse effects of climate change. So today's panelists were selected because they're changing the paradigm. They are, rather than designing buildings in a defensive mode defending it against nature. They propose to design holistically, working from the outside in, allowing ecosystems and ecologies to inform and transform the sites and their developments. So we have a very, very short period of time. Each speaker will speak on a different aspect of ecology, starting with Earth. And I'm hoping you'll find these very delectable, almost like a box of 3 chocolates. Each one is really interesting, really delectable, and will leave you really wanting to find ways to put these practices to work in your own buildings. So the first panelist will be Paul Kephart. He's a principal ecologist and landscape architect with RANA. He has a wonderful portfolio. I'm sure you're all familiar with much of it. The Trans-Bay Transit Center, the California Academy of the Sciences. He really represents a transformation of the way we are thinking about buildings and ecology, and thinks about buildings as almost living systems or living architecture, as he calls it. And he's worked with many of our preeminent colleagues, from Pete Walker, Cesar Pelli, William McDonough, and Renzo Piano. After Paul speaks, Tom Phillips will speak. Tom is a biophysicist and a physiologist. I think that basically means he's a rocket scientist. He spent 40 years working at the intersection of research and policy, addressing health, pollution, and buildings. And he has been a technical advisor to national and state and local agencies. But his focus today will be on the interconnectedness of ecology, human health, human society, which I think is very interesting, and air quality. And then our final speaker is Seth Parker, who is president of the Pacific Land, Water, and Home, as well as Pacific Fire Management. He is a native to California, native to the Big Sur area. He's had on-the-ground experience with wildfires. He's also an arborist, a water auditor, a CAL FIRE timber specialist, and a certified ignition specialist. And when I first talked to him about fire, I was blown away. It's a really different perspective. And so with that, I will turn it over to Paul.
Thank you very much. It's a great pleasure for me to speak with this panel today and talk about the intersections of ecology. And as an ecologist and a landscape architect, I feel our primary job is to make a bridge between the natural world and the built environment. And one of the ways we do that is we've developed an ecological design criteria that's holistic. It looks at water, including wastewater, stormwater, nuisance water in the built environment. It looks at waste, energy, biodiversity, human health and well-being, soil and food. And now with the challenges around climate change, we're looking at bioclimatic architecture, or this kind of a new phase of organic architecture that really takes into account environmental factors of site analysis, including orientation, wind speed and direction, slope, aspect, materials. And with these criteria, we focus our work on improving the performance of the site and structure. And that's for either for the energy use or carbon sequestration, or adapt to these changing climates, or for biodiversity. And one of the projects that as a case study for biodiversity is the California Academy of Sciences, where we've established over 100 species of indigenous plants, and recent research has shown that there's 86% more species abundance on the Academy than anywhere in the Golden Gate Park, and 36% of those are not found in the park. So this was a manner in which we were able to create a corridor, a habitat corridor, and provide connectivity between regional open space And it's to the benefit of those creatures. So when we're thinking about the earth and we're thinking about our designs and our sites, we approach that with reverence towards those creatures that may have lost their homes or been displaced and have an opportunity to return. In regard to water, water is that key element most precious of life. And water, we found in the built environment, is very much related to energy and the use of wastewater. For example, on the Vancouver Convention Center, the lavatory water was diverted from the sanitary sewer into bioreactors, purified and then polished, and then used for a 6-acre green roof that supported habitat. But one of the outcomes that were unexpected was that the structure is among the largest exhibition halls in North America with a high energy use, and the thermal modulation from the irrigation, transevaporation, and that thermal barrier on the roof from the soil took the peaks and valleys off the energy demands and therefore reduced energy use significantly, so much so that it paid for the rooftop and the water waste recovery systems within about 3 years. So when these sustainable measures work from an ROI standpoint, it really works from a sustainability standpoint. And therefore, the carbon footprint of the building was reduced as well when energy was reduced. In terms of our adaptation to climate, our current research in the West has shown from 200 years of study that our average temperatures are increased some 5 degrees. Water and rainfall has stayed fairly much the same, and more frequent rains and more diversity of the type of rainfall pattern, but the rainfall has stayed the same. But the temperature has increased by 5 degrees over the last 200 years. That means that we need 5 inches of rainfall or precipitation to overcome every 1 degree of temperature increase. And given that our temperatures will continue to increase over the next 20 to 30 years, becomes this idea of adaptive or this bioclimatic type of architecture becomes almost a point of survival for our societies, and that buildings are going to need to we need to innovate around passive ventilation and materials that can provide bigger and better performance around insulation. And all this could be found in natural systems in terms of typologies of earthen structures, for example. Again, designing for the wind and shade, plant materials that can screen and shade the building, that can also modify the structure. And then this idea that air handlers don't have to be placed on the sunny, hot side of the structure, but instead could be on the cooler side and have a biological barrier of a wetland system or a shaded plant material that conditions that air as it enters the building. So these are just a few examples of the kinds of biological interventions and some of the ecological design criteria that we use. I want to turn it over now to Tom, and he has some information for us to continue the discussion.
Okay, I'm going to try to do my desktop. you for inviting me to join you folks today. I'm going to try to talk about how everything's connected basically in the ecosystems and human systems, and talk a little bit about the indirect effects of ecosystems, as you see here, in terms of the green highlighted items. Climate change is affecting the microbes, the allergens, the water and food supply, and the environment and habitat, and all these things can have major effects on public health. We also are seeing more and more effects, direct effects of extreme heat, where it can have long-term and chronic effects on various types of illness and hospitalization and student and worker performance. And then for severe weather conditions, we can have power outages, wildfires, mold problems from flooding, and so on, that all have major impacts on health. So they're all kind of direct and indirect effects of the ecosystem. As Paul mentioned, we're seeing major shifts in temperature. Here's just an example. In the first decade or so of this century, we already see a major shift where we're getting a lot more extreme weather, as you see on the right. And we're also getting more variance. The curve is flattening, but it's spreading out. So we're getting wilder weather too. And this is continuing as we speak. We see more heat records broken every year. We're seeing Arctic heat waves and wildfires and sea ice loss. And even desert locusts are coming back. So it's kind of like the four horsemen of the apocalypse sometimes. What's really concerning, I think, the global modeling people is the marine heat waves are increasing. And that's the climate buffer for absorbing heat. It's something like 5 nuclear bombs going off every minute or something is the equivalent energy that's going into the energy. And so it's becoming overloaded. And we now see, like on the right, the heat wave last 2018, the coast off of Southern California was warmer than Hawaii. And we got this pretty heavy duty June heat wave in the South Coast. And it was very humid also. So all this creates major stresses on the food and ecosystems. We're already well into a mega or multi-decade drought in the Southwest, and a high risk of desertification by the end of the century, dust bowls basically, where ecosystems are destroyed as well. And we're also seeing major drops in the world's fish stocks and overfishing, as you see on the right. And the good news is there's some research underway to develop climate-ready tree, vegetable, and grain crops that can handle future climate, we hope. Here's an example from UC Davis and the Forest Service. They're looking at tree species that would be more resilient in the future warmer climates of California. And they're looking at Northern and Southern California, 12 species over 20 years. They're several years into this study. I looked into this when we were replacing one of our big shade trees. And so I've been getting ready to plant one of these trees. And excuse me, they're looking at various factors in terms of soil and pests and weather and carbon sequestration. And you can get preliminary results from them in presentations on this website. And they're already implementing some of this at the International Oak Collection at the Arboretum here at UC Davis. They're planting Texas live oaks. So that's pretty cool. And so why do we want to adapt buildings and make them more resilient for climate change? Well, there's lots of good reasons, depending on whether you like beer or wine or whatever, but there's also major health benefits. And when we look at health risks from extreme heat and air pollution, we typically look at not only the climate and the environmental hazards, but the socioeconomics involved and energy and land use and all that. And you folks have been focusing on land use and ecosystems, but building practices are very important but often ignored, but they have major effects on both the indoor and outdoor quality. They also affect, and they're important in terms of how the building could be adapted to be more protective, and also how to help identify the populations that are sensitive and more susceptible to these impacts. we're now finding that thermal health is much more than just whether or not you're comfortable. We're seeing major impacts from research studies in terms of student performance, worker performance, and that has major economic impacts as well. And this Harvard program that's cited here has summarized and done a lot of that research. And so this is kind of an emerging field, but it's one of the many things we have to look at for the indoor environmental quality, or IEQ. And this is just to show that in California, say for Sacramento, by mid-century, we're going to see a lot more of these extreme heat days, the over 98th percentile. So that means we need to be designing buildings for 60 or 100 years if we want to be sustainable. So you have to factor in these major climate shifts. And also so we're looking at, when you look at the yellow and orange dots, those are not just 98th percentile, those are like off the charts. It's 110, 120 degrees. So you're talking about Arizona type weather, basically. Also, heat waves are going to get longer, and this just shows you the general trend from the climate models in Sacramento. They're going to go from about 2 to 10 days per heat wave, which means if you have a power outage, which is likely when you stress the grid that long, how do you design a building for that? If you can also look at the cooling degree days to get a rough idea of how you should design a building. And you can see that, say for Bakersfield, you're going to almost double the cooling degree days by mid-century and triple it by the end of the century. And all of a sudden, you don't have much heating load. So you need to really rethink how you design your building for mostly cooling, right? The other reason to address this thermal health and climate issue is what we call energy poverty or burden or inequity. There's a lot of people, especially low income, that can't afford to run their air conditioner or retrofit their house or repair their air conditioner, or they don't even have it sometimes. And so this just shows you that it's pretty widespread through the US, and in low income households, it could be over 10% of their income is spent on energy. And so say in a recession or anything else, they're the first ones to really suffer. Now for an architect, there's real obvious reasons to address the need to prevent overheating and adapt to climate change. And I assume you're aware of the AIA Code of Ethics. I did double check it, and it clearly mentions climate change and health and sustainability and disclosure and due diligence. So those are all things that we should be doing. There's going to be more and more, I think, benchmarking and reporting of energy bills, and maybe eventually overheating risks. But there's already some major lawsuits in California, in San Francisco and the Central Coast. There were about 11 deaths in Florida from a power outage at a nursing home, and so there's a big lawsuit over that. It's a common complaint in new homes in California, and it's also a risk for low energy homes if you don't control the solar gain. So how do we adapt the buildings? Well, we do an assessment. We look at long-term impacts and short-term impacts from power outages. Then we design and optimize. And right now, most people are optimizing for energy and cost, but won't necessarily protect you from overheating risk. You still need to address that specifically. And then best practices to install and commission the measures, make sure they work. And then there's often fiscal constraints up front because it might be cost effective over the long term, but the cash flow is an issue. So some people are getting subsidies, and they are also phasing in measures where they build the substructure for a green roof, or they put in bigger brackets for more shading in the future, and so on. And then update your vulnerability assessments periodically, because this whole picture is changing all the time. You can get a rough idea of what kind of climate you should be shooting for by looking at the climate degree days that are available. And so for Fresno, you'd want to be designing for Arizona, probably around Phoenix. And people are already doing zero energy type homes in Phoenix. There's Mandalay Homes, award-winning. They are totally electric, battery and PV, and market price, low carbon, good indoor quality. But they haven't evaluated it for overheating yet, as far as I know. But in the UK, they have done that. They've designed it for future weather data. It's a big development that's starting up, and they're looking at various time periods and building types. They also do look at landscaping and occupant training. And here's some examples of the designs they're looking at. They have good external shading, shutters, and landscaping and buildings. Here's a whole new wave of multifamily tower retrofits going on in Canada. They've got some government subsidies, and they're using future weather projections to test thermal comfort. They're getting super GHG reductions. They're also assessing what happens when you get a power failure. How long will it stay warm in the winter, and how long will it stay cool in the summer? And they're getting big improvements there. You know, maybe not enough, but very good for an old building. The UK has a lot of demonstration projects, and at the neighborhood scale as well as various building types. And they have delayed some measures due to financing issues, but they're doing case studies as well. Australia has done some modeling of how their low-income housing performs under heat waves and how to do moderate or intensive energy retrofits to improve the overheating performance. And they've been able to show that that can be very cost effective. There's a lot of guidelines being developed out there at the international level. Here's some examples from the UK and Passive House. And they use different metrics, but generally the UK ones use the future weather data they've developed, which is the key thing. And ideally you get hourly data, but some people are just using monthly averages, which is better than nothing, I guess. They factor in urban heat island effects too, where they have good data. In fact, that's required in London now. In North America, we've got a few examples. Build a Green and the third item, Collaborative for High Performance Schools, have kind of built on what LEED has done to develop credits for resilient design to factor in future overheating risks. British Columbia last year was the first one to actually put something in their building code that specifically requires people to address overheating and air quality impacts from future climate. And there's a lot happening in California. I didn't put on here building decarbonization, but that's really a big program with funding now at the state level to push electrification and in retrofitting. So that's, I think, an important opportunity to address overheating risk and health improvement. There's CalAdapt as a tool I showed before that's really fun and interactive, and we can play with that if you want. There's been some updating of weather files, and just recently Altostratus at the bottom is now producing future weather files at a fairly good local spatial resolution that not only reflects climate change, but also urban heat island and land use. So the bottom line, if I have time, is that there's at least 7 good reasons to do future proofing and resilient design and climate adaptation for buildings. And I would definitely say, you know, it needs to be an integrated, holistic approach to look at not only the building itself, but the landscaping around it, the other buildings that shade it, and affect natural ventilation and so on. And so the obvious ones are energy and cost and GHGs. And those are kind of the pocketbook type items. But the big health and social benefits are the benefits for health, excuse me, air quality, grid resilience and power outages, and survivability, I guess, during power outages. And then something that I think your clients would be interested in, the last two, improve property or rental value. We were already seeing this for green buildings in general, but I think as best practice starts to incorporate overheating assessments, we'll see more and more market response to that. And also reduce liability to avoid some of these nasty lawsuits and comply with your code of ethics. So in Texas, you know, when they have a problem, they have pretty severe weather there, so they know who to call. But we want to go to another higher power, I guess, and make sure that we act now and start moving towards positive carbon and removing carbon from the environment, and do the right thing for the future generations. So thank you very much, and feel free to give me a buzz, and we can discuss and share information. Thank you.
Seth will now talk about something even hotter than our climate.
Hi, everyone. Thanks for having me. Really excited to be here and speaking with you. First, I'd just like to kind of reach back to Tom and Paul and just reiterate that everything is connected. And it's really important to understand that connectivity. For every action, there's an equal and opposite reaction. And so it's really important to understand what you're doing and why you're doing it before you do it. Having said that, I'm gonna back up a little bit and just talk about the history of fire on the planet. According to Stephen Payne, he's a renowned writer on fire, there were great periods of time where there was no fire on the earth. It was a water world. And presumably it was dried seaweed and electrical storms that created the first fires. And you can take that all the way up to these times where there was great periods of volcanic activity and essentially the planet was on fire, or, you know, a meteor struck and you know, just put the whole planet into a conflagration. And I mention that because there is a giant pendulum swing. Climate is dynamic, and the idea that it is static and what we are experiencing is quote unquote normal is foolish. What's normal is change. And so one of our problems as human beings is we have a really short memory. You know, we're basically around for about 100 years, and that's what our institutional knowledge kind of holds. And so as recently as about 100 years ago, most everyone remembers the Great Chicago Fire, right? In 2 days, October 8th through October 10th, dry conditions and heavy winds caused a fire in which 300 people died in 2 days and 100,000 people were displaced. Not many people remember in Wisconsin, there's the Peshtigo fire, where 181.5 million acres, roughly the size of the state of Connecticut, was burned in a night. It was the same day, October 8, 1871. 1,200 to 2,400 people were killed in a night. Nobody has any idea of the real number because all records were burned. They lost 2 billion trees. I mean, picture that, 2 billion trees in a night. Rail cars were actually, the fire tornadoes in that incident were so extreme that rail cars were actually picked up and tossed across town. I mention that because nobody remembers it. It's the largest fire in American history and nobody remembers it just over 100 years ago. And so moving forward and talking about us as human beings, I think we have this unrealistic relationship with fire. It's like the old Frankenstein, you know, the Saturday Night Live skit where he goes around and says, fire, bad. Well, our relationship with fire is much more complicated. And I think about fire, water, earth, air. Take one of the other three out and see what happens to us. We are very, very dependent on our relationship with fire. And, you know, to emphasize that, I point out we don't have fur. We can't see in the dark. And most of what we eat would kill us if we didn't cook it. And so because of that, I would theorize that human beings basically have two purposes in the ecology, right? We spread fire and we spread seed. So taking that all and putting it together, coming back to you and architecture, is that we do need to plan for the future. Our climate is changing, it's getting hotter. And I would put forward that perhaps the last 100 years have been a relatively mild in terms of fire climate, and that is actually the aberration. And normal fire conditions are much more extreme. And having said that, again, going back to Tom's comment about planning for the future, planning for increased heat. Well, with heat comes fire. And so our design should be preparing for that and looking at a sense of place. We are moving, more and more of us are moving into the wilderness, to what they call the WUI, the wildland urban interface. And in doing so, in moving into nature, there's a responsibility to cohabitate with that nature. And fire is a part of it. It's really interesting. The difference between a wildfire and an emergency is you and me being in the wildfire, right? So as soon as we move us into a wildland area and a fire comes, we want to put the fire out. If there's no one there, the fire burns. And that is natural. That is what's supposed to be occurring. There's many species of plants that are dependent on that heat to scarify their seeds and allow germination. It's regularly understood that fire helps cull the weak and creates resource for whether it's a tree or a rabbit or, you know, whatever it is, it creates that resource that makes a stronger habitat. Another thing that's fairly commonly known is that, for instance, it's not coastal chaparral, it's coastal prairie that has the highest value for habitat. And really interesting. So the plant world, they're having resource wars, right? So chaparral, for instance, puts out an enzyme that makes it hard for grasses and flowers to germinate. Well, what it does, it makes the soil alkali. Well, how do you make the soil, how do you balance the soil? Potash, right? Set it on fire, boom, you have these amazing flower and grass shows after a big fire. And so what I would encourage everyone to do is, instead of trying to quell fire or being afraid of fire, embrace it and figure out how we can work with it and benefit from it. That's really all I have.
Great. Thank you. So I have a couple of questions that I'll just start off with. The first thing is that California is not just a mosaic of landscapes, but it's also a mosaic of social types and housing types. We have inner cities and we have WUIs and we have truly rural and we have suburban and we have all different things, all different types, patterns of habitation. How do you three think we can bring some of the issues you're talking about into, for example, the inner cities, the people who are now most affected by thermal heat gain, maybe not so much about fires, but we've seen fire, I think it's this in Santa Rosa, we saw it burning cities even more than, or suburbia, even more than it was burning the natural setting. So do any of you have ideas for how to intervene and embrace ecology when you get to the level of an inner city? We'll start with Paul because it seems like the most complicated part.
Well, it's really about available surface, right? And in the urban environment, what do we have? We have walls and roofs. Everywhere else is taken, and we're at a level of very high density. Air quality is challenged, noise pollution, the living environments are getting pretty tough. The heat island effect is, so when I look at the city, I see only opportunity. Our urban parks and urban forestry programs, we have to keep them funded and keep moving in the direction of planting more trees and more canopy. But in terms of design and architecture, and where you're either doing retrofits or new buildings, by all means, take advantage of the surfaces we have. And in that way, we can collect and purify more rainwater. We can thermally protect the structure, and we can enhance the habitat and environment for all the creatures that live there.
So just before we move on to the other speakers, one of the things you and I talked about was the value of a green roof in a Mediterranean climate.
Mm-hmm.
And I'm wondering if you could address this, because I thought you had a very interesting take on it. Our initial response is we don't want green roofs because we don't have the water to keep them living. But you had a really different perspective that I think would be informative.
Well, when we think again about ecology, we're looking about, Aldo Leopold said it best: if you take apart the watch, make sure you keep all the pieces if you want the watch to work. And so when we look at a green roof as an intervention for the benefits that I've outlined, and then you think about water and water scarcity here, well, where are those opportunities for wastewater, gray water, black water? In California, we have underground parking, a really common situation in California. We build on expansive clay lenses, and we cover up springs and water sources and nuisance water, and the concrete cracks. The water enters the building, and then we have fresh water that we pump out of the building as nuisance water. So I look at all those kinds of opportunities. Cooling tower blowdown. The new cooling towers use electrostatic rather than chemical purification measures. That water is available, reclaimed water is available. And when we do an analysis and look at the water sources for the stormwater harvesting, gray water, black water potential, nuisance water, all of those potential sources, and quantify those, we usually end up with more water than the landscape needs. And this is really where the industry is going in terms of landscape architecture and design in the arid climates, is focusing on net zero and still gaining those kind of positive benefits that vegetation brings to the city.
Seth, what do you think about fire in the cities?
Well, it's really interesting. A lot of fire in the cities are man-caused. And so it's very much by design or design failures that they happen. A broken gas main, tire fires, there's a variety of different things. But what Paul's saying is, I think is critical. It's to reuse your water and then keep your vegetation green, because green vegetation is hard to light. The flip side is, if you do a bunch of roof, green roofs, and then they turn brown, you have a potential ignition point. But earth is a remarkable insulator, so it could burn off a lot of the roof stuff and the building would still be safe.
Interesting. And Tom?
Well, from the public health perspective, from the big fires we saw last few years, the cities can get blasted with wildfire smoke and have Beijing level particle levels in the air. And then you want buildings that can shelter them from that, and air cleaning and air sealing and all that. And a lot of buildings don't have that. And so what do we do? I think clearly the mantra for air pollution indoor and outdoors is control the source. And people are working on doing better management, controlled burning, ecosystem management, checkered fires, and trying all kinds of things to avoid these firestorms and mega fires. So that's number one, control the source. Number two, for general public awareness, I talked about urban forestry. So there are lots of opportunities there at the urban suburban level to have resilient and sustainable forests. The key is to manage them. You know, when you can't afford the water, and especially in, say, in low-income housing or rental housing, and maintain them. But also the urban forestry people at Davis and elsewhere have good programs to have a mix of species. So you don't have diseases coming through and wiping out the whole population and so on. And so they have a whole matrix for selecting the right tree for the right place. And then there are the basic nature connections that we need to really foster with children and families and everybody. And that can start at just the local garden level where you could use gray water. And you have also you know, good healthy food that's being produced for food pantries or local people or whatever. And then also trying to rebuild the outdoor experience of nature of kids. You know, I discovered on a backpacking trip that they used to bus in low-income kids from the Bay Area to the Sierras, and that has gone away for various reasons. And so, you know, the social community support for ecology and wilderness and so on needs to be rebuilt and supported because it's a bipartisan issue. But we now know that there's actually health and psychological benefits to that too. And there's some HMOs that provide free park passes, like in Moran and elsewhere, I think. So that's kind of my response to the question of tying up ecology and wildfires and public health.
You know, if you don't mind, I wanted to mention one other thing, and that is that so much of wildfire and fires are, again, connected to climate change. And, you know, cities are huge producers of carbon emissions. And so, of course, you know, managing that, whether it's rooftop gardens or, you know, mass transit or, you know, possibly even white roofs instead of black roofs, you know, those things actually, you know, everything's connected. So they lead back to themselves and make, you know, make everything better.
Good point. There's a comment from the audience. I don't know if you all can see it, but I'll read it to you. It says, mention that what we build with matters. We use a lot of materials that have toxic emissions when they burn. Foam, insulations, and vinyl siding come to mind. So Seth, what have you run into with that?
So yeah, I've actually done some pretty substantial cleanups post-fire. And it's remarkable. They have to come in with bunny suits and check everything out and make sure that you can actually go on to do the cleanup. And in one case in particular, we weren't allowed to do some cleanups and a rainstorm came. So we just washed all the chemicals that we weren't allowed to go into the environment, right? And so it's one thing to really consider is, you know, what the use of this particular product is going to mean down the road. And the other kind of thing that I'd like to put out there is that we have, you know, we used to light fires. The Indians for thousands of years lit fires, right? It improved hunting habitat. It improved, you know, made the trails easy to go, and generally made it safer for them to exist because there wasn't a bunch of fuel there that could catch fire and burn them down, right? So we've changed that for, you know, cars or whatever our particular carbon emission is. And I think in the future, the only really affordable way to do vegetation management is to use fire, but we don't have the carbon space to be lighting the fires. So if back in the urban, you know, in our urban building, if we could start to change that picture so that we could light those natural fires again and create a safe space, I think that might be a goal worth pursuing.
I always remember something an ecologist friend in Ashland told me, and his wife was working for the Forest Service too, and they're seeing this up in the Siskiyous where they get these fires and you know, and it wipes out part of that ecosystem. And what tends to come back in is invasive species.
Right.
And and it changes the whole ecosystem, but also it reduces the carbon intensity of that environment, and it tends to dry out. Mm-hmm. So you get this vicious feedback cycle. It burns, and then it gets drier and hotter, and you lose less and less carbon. So, you know, that's another good reason to manage the fires and prevent these catastrophic fires. The other thing I remember is that, you know, when we were getting huge beetle damage to, say, the Canadian forests, millions of acres, for a long time, there wasn't any plan to plant something that would be more sustainable and resilient. Mm-hmm. So, you know, that's another thing we need to be thinking about, not just for urban forests, but maybe wild forests, is what kind of landscape, you know, are we going to have to nudge in the right direction?
I think we have a question here that I actually can't see it's on the chat. So let's see. We have a question from Daniel Soble. How do you all feel about the prefabricated home movement or buildings out of steel?
Well, it's a booming thing. I know. I just followed up on a Forbes magazine article that talked about the industry trends, and it's booming. It's already happened a lot in the Europe and maybe Asia, I don't know. And it's being driven a lot, I think, by affordability and labor shortage for, you know, stick-built type site-built homes, because you can drop in even a panelized home, you know, and have the basic structure up in a few days. And the energy efficiency and performance is generally very good because the quality control of the factory is good. In fact, in Vermont, they were doing net zero manufactured housing for low income people, and I think pretty low carbon. And they could set up mobile manufacturing facilities and go to different regions and do that. Now, in terms of steel and concrete, yeah, we always want to try to minimize that. But on the other hand, if you can go multi-story, you can have an even more efficient building, a lower footprint on the ground, and preserve your land for ag and people, you know, walking and biking or whatever. So I tend to think it's the wave of the future for various reasons, and I think, you know, it makes more sense than the way we're building homes now. And also, the other factor that's pushing it, especially maybe California, is the need for ADUs, accessory dwellings. And well, I've seen some in my neighborhood, and you know, we're looking into it.
So I have a question that has been intriguing me. We are all practicing sustainable building and sustainable site development, and we use LEED or other means of measuring it. Is there something we could be doing more in terms of really recognizing the greater ecology? Not just what's at our feet, but maybe seeing a little further into protecting soil, and the effects of climate change on soil are just coming out, that it is changing our soils, and that will change what can grow, and that is being changed by the invasives that are taking over. So do you guys see any a stronger movement towards a stronger kind of design set of measurements or guidelines?
Well, on the kind of a negative sense, one of my observations, you know, I come from a small town, Big Sur, California, and very rural. And over the 40 years that I've lived there, there's been a lot of build out. And the interesting thing, when I was a kid, there's a thing that said, you know, everyone drove their Mercedes down there and turned them into chicken coops. Now they've sold their chicken coops and have bought Mercedes, right? And what's happened is all the people that have moved down there have built these massive homes. And my recollection is you moved to Big Sur because you love the environment, you wanted to be outside and be in it. And generally speaking, whether they're LEED or not, I noticed that most of the houses maximize any available space. They occupy that place. And where when I was a kid, you could live in a garden shack and go out and play, and you know that was your experience. Now you have big plate windows and you look at it. And I think, you know, as a trend in building, people ought to take a look at themselves. We have less and less children to have space for, and yet our homes are getting bigger and bigger. And so I just think that right there would move the dial.
That's a really good point. I certainly see that as I just walk on my blocks in Los Angeles, that every square inch is built on, and there is no room to percolate water through the soil. So interesting. Paul, did you have any thoughts about that?
Well, along with that scale that Seth has mentioned, I think more attention to site-specific environmental factors. We do have LEED, we do have Living Building Challenge. We're beginning to address those kind of performance issues around energy and waste and water. But for me as an ecologist, I find that we need to look at capacity, a site's capacity. We need to look at its adjacent and those kinds of habitats that are in close proximity in order to capture those values that we all want to protect and share. So as architects and planners, we have the ultimate responsibility to educate our clients that these are also important values. And perhaps that's where we start, is with an understanding of values and principles rather than materials and scale and style and footprint and what have you, but to really think about with our clients what's important in their area that they live in. Social justice, human health and well-being. Now with COVID, that's going to create a whole new series of design criteria that will change the way we see the world, change the way we design buildings, and change the way we design landscapes forever. So those are just some of my thoughts on where we're headed, but I really agree that with Seth about his comments about, you know, we're kind of using up more resources as individuals than we probably should, and maybe a reevaluation of that would be helpful.
I agree. That's a good segue. We have probably time for this one last question. I'll read it quickly. It's from Fanny Wu. I feel there's been a disconnect among civil engineering, landscape architecture, and architects. Oh, do you think so? Sorry, didn't mean to let you know my opinion there. How can we collaborate to design better for the ecology? That is the million-dollar question.
Well, I'd love to take that one on because, you
Really?
know, we get into this tussle around form and function. And, you know, civil engineers are designed, they design for performance and hydraulics and water capacity. And I think the key is that we need to work as collaborators more so that the disciplines aren't siloed and that we can learn from each other as engineers or ecologists or landscape architects or planners, that all of these are interconnected. And that's where we like to start. We're great collaborators. That's what gives us joy and delight and energizes us and provides inspiration when we can see how the engineering world and the architects and the landscape architects really commingle their strengths to produce really great places of beauty.
So I'll tell a brief story and then we have to end, but I think you're right, Paul. It's education and collaboration. And I heard a story recently involving Seth, actually. He probably doesn't even know the story. He was down at a Big Sur site with another landscape architect and an engineer of some sort. I'm not sure what kind in this case. And they were talking about developing the site for private residents with regard to fire. And the suggestion of the engineer, who I am not going to malign because I don't know who it was to remove all the trees from the site immediately as a way of making the home fire defensible. And that probably is exactly what we don't want to be doing when we go forward. We want to find ways to work with those trees sensibly and intelligently, and make those trees part of our defense against fire rather than just cutting them down. And so maybe that's really what we're talking about when we talk about the intersection of ecology and architecture, is really to look at it as a holistic environment, and that environment even goes beyond our site into social cooperation, at least in a hopeful world. So I don't know if we have time for more questions. That would be a question for Katie and Hillary. But we do have
one or two. Just want to be respectful of our attendees' times, but
Yeah.
we will send the questions to the panelists and have them answer them, and we'll provide them on our Design for Ecology website.
Okay. So the last question wasn't a question, it was a recommendation on how to collaborate, and it was a good one. It's from Ian Merker. It's how to collaborate, share your passions in a kickoff meeting, and follow up with regular face-to-face or Zoom discussions. Don't go too far down the wrong path.
And integrated design through chips and LEED and all that basically tries to incorporate that, having all the disciplines meet early and often, do the planning up front and clarify what the design goals are.
Mm-hmm.
And try to avoid the least cost engineering, where it's just strictly cost based and not holistic. And that's one reason why I stressed optimization models, because you'll often have different goals, but you can find some of the much better solutions, and there's more and more software out there that does that.
Good. All right. I think that that ends our discussion today, our webinar. And as Hillary said, if you have any questions or any other things that weren't answered, we will be able to get that to you. And the AIA staff, very nicely, will submit your AIA will submit you for your AIA credits. I hope me too. And I think that's my conclusion.
Thank you. Thank you.
Thank you, everyone.
Thank you all so much.
Thank you, everyone.
And Seth, I sent you a question.
Oh, great. Can't wait to answer it.
You could
Okay.
probably call them.
Thank you.
All right.
Okay.
Thank you all.
Bye.